Classic. I was muted. Good mythical morning. Good Monday morning. Um, let's see. It's hard for me to tell if the music is loud or not from your end. So I hope everything sounds good. I woke up this morning and I was like, why did I wake up at 6, 7? What is it? 7. Then I was like, a bit annoyed that still haven't managed to finish yesterday's puzzle. And then I thought, okay, so what's today's puzzle? And I had a look at it, and it is pretty interesting actually. And I, I think just from reading it, I may have a solution. It also sounds more like, uh, yeah, like Python NumPy. I think we can solve it relatively easily. It's actually, if you're familiar with, it's convolutional-ish task. Um, so today we are in our submarine. We have deployed our, unfortunately, we haven't really deployed our scanners, but well, according to the puzzle, we skip ahead and we have, let's say, deployed our scanners, and they are mapping the ocean floor now, the trend. Mapping the floor of the ocean trench. So now we want to see how the the floor looks like. So the scanners return an image, which looks like random noise, but it's actually not. So it returns two things. It returns a an a line, like a series of strings that is either dots or hashes. Dots means 0, hashes means 1, and this is one long line, basically, even though it wraps around here. Um, and this is an example input here. So the top one. Um, so actually, I'm gonna copy these so we will work on those as usual. Just make sure we can solve the example before we test our own input. So basically, what happens here is we have to do something on this input, and what we read from it should be mapped into this input. So we can keep reading here to give it a better idea. Right. So the first section now, okay, they call it the image enhancement algorithm. So basically, what will happen? We will do enhance. It is normally given on a single line. I don't remember. Did I say good morning? Good morning, everyone. Welcome to the stream. It is normally given as a single line, but it's been wrapped to multiple lines for legibility. Yes. Yes, all right. So each hash is a light pixel and each dot is a dark pixel. The second image, yeah, is an input image and it's two-dimensional. Yeah, so the enhancement image basically um, takes each pixel and tells us, we use that as a reference to know what the pixels should be. And in this case here, basically what we have to do is we are creating a 3x3 image, a kernel, basically, if we are familiar with convolution, and we're scrolling that through the entire image. So basically, in their example here, I think it's easier to see when you look at it like this. They start by looking at the pixels that are inside these brackets. So these three, and these three. So this is a 3x3 convolution. Although they don't really perform, it's like it's maybe not a 3x3 convolution actually, but it's a 3x3 filter, I guess, that scrolls over the image. Or you could argue it's a kernel at least. So basically, what we do is we read these 9 pixels, 3x3 here, and we convert them to binary. And that binary will be something Right. They explain down here that it will be it could be from what is it? Yeah, this is the specific. In this case, they map. Yeah, exactly. So this is the input they read from here. 3 1 0 0 0 1 1 three zeros 1 0 0 1 1 0 1 1 0 1 0. And in this case, if you take this and convert it to binary, it will be 34. So let's also start here a new branch. Um, Actually, I'm gonna start it from the main branch. Um, let's. How are you doing in this mythical morning? Let's pull. Do always pull before you create new branches. Make sure you're in the latest version of your main branch. Um, let's name this branch left day 20. Perfect. So now we can close all these. And go here. So let's create our um not this one actually. Let's create this one. Day oh, day 20. I pi and b. And let's start by pasting in our input example. Yeah, I first wanted to also show you print um, this what this integer is. Sorry, what this um, binary is, and we have a way to already cast it. Let's say, so basically, this is a. Submarine. Will it crash? So basically, Python has from a certain version and on, it has these f strings. Okay. Does it need to be a string, maybe? Okay. Maybe we need it double quoted. Unknown code format. Type string. Does it need to be B here? Bytes. No. No. Ah. Okay. Wait. I have an idea. Ah, right. Okay. I've been doing it the other way around. Sorry. Um, I've been trying to cast this into an integer. Sorry, into a binary. So an integer into a binary. So basically, okay, I got it wrong though. I was thinking that maybe we can do it the other way around as well. We have to look into documentation. So, yeah. By the way, I'm working at 9, so we have at least definitely that deadline. We're not going past that at all. Right. So basically, what I want to do now is to have a good way of converting binary to integers, pretty much. So let's try this out. I think. So yeah. So at least we can do this. So we can create a binary string, a string of binaries. And then we, let's see. I'm gonna have to close all these extra windows here. We don't need them now. We may come back to the puzzle, the yesterday's puzzle, day 19. We'll see. But not today. I got the feeling that we can solve this one. So, let's think. Right, we want to convert binary to integer. Yes, maybe with can we do it with f strings? That would be pretty neat. Actually, maybe even look at Python string formatting. In the documentation, please. Mhm. Let's see. No, we don't want. But we have. Wait, we have the format here somewhere, right? Formatting syntax. Okay. This is the kind of yeah. This is the old way of doing this. I mean, I guess it's not old still. It's pretty valid still. But we format string syntax. We want to format spec. There we go. So we want the format spec described in the next section. Okay. So we want to know if we can convert a binary to maybe string to an let's see an integer. Yeah, wait. We should be able to do this with, instead of doing b here, we can do sorry, d for digit. And let's try this maybe. I had this one here. Unknown format code D for object of type string. They have a meaning somewhere about each of these types. Yeah. String, this is default type. Okay. Binary format outputs the number in base 2. Character converts the integer to corresponding Unicode character. No. Decimal integer outputs the number in base 10. It needs an. It sounds like it needs a numbering. Number the same as D, except that it uses a locale. Hex format, octal format. Wow. There's present. This is just presentation mode. Precision, scientific, percentage. Okay. Okay. Not very happy about this. I thought we could do it pretty neatly, but well, that's fine. We can keep on searching. So convert binary string to integer. Can we do this? Oh, by the way, I love this feature of DuckDuckGo that it just shows you the answer here. Okay. That works. I didn't know. With the built-in function int. That's super cool. Yeah, let's do this. So if I completely remove this and this, we should be able to cast it into an integer, and it had is it how many a base? By default is 10, but because what we give it is binary, so it's base 2, we give it 2. I love this. I did not know this. Nice. We learned something today. And it is 34. That was so fast. Nice. Or, I mean, depends on your definition of fast. I talk a lot as well, so. Yeah, I hope you are enjoying your morning brew. I'm having here a good morning frappe, all the way from Greece. And let's see now. So yeah, so we took this number, turned it to 34. Perfect. So we already have our. Let's just create a function out of this right away to make it simple. String to, or like to int or whatever, and then it's gonna be a binary string as a string, and it will return a integer. So So basically now, that's binary. Perfect. So this is our function. So now we can do to int for any binary number. So we can place this in. Oh, and it even nice. It even cleans the wow. Python is too kind to us. It even cleaned my like bad spaces here. Yeah, look at that. That's really neat. That's perfect. So then if we do this, it's going to be 35. Yes, amazing. And then that's 36. That's nice. And perfect. Let's do so. So we have our integer function. Let's just add some quick documentation. Cast convert strings to strings that are binary numbers to integers, and this is string binary number depicted as a string, and then the integer number from this binary string. Perfect. And it's always nice to write documentation. So this in Python, when you write documentation like this with these three, also yeah, I have a plugin in VS Code that I have a lot of plugins in VS Code, but I have one that goes. It's called Better Comments, if I remember correctly. Yeah. This one. Yeah, sorry. Python doctrine generator. It's super cool. It automatically reads my inputs to the function, the name of the function. I mean, the name doesn't need, I guess. The inputs and what the outputs are. So it automatically figured out my binary input is a string. My binary argument is a string, and then it just asks me afterwards to add the description for that. So I don't need to add this. It also auto creates a structure for the documentation, and then it knows from here actually that it returns an integer, not from here, and then it creates that as well. So if we go in here and we do this, look, we have documentation for our own function. That's pretty cool. So yeah, convert strings that are binary, blah blah blah. Awesome. Please do that as much as you can. It makes your code super nice. So we don't need this now. Let's create our so let's make this day 20. I'm probably gonna write something later, and let's write here helper functions, and that's gonna be our helper functions. And then here we do our loading stuff, and let's do our input, example input in here. And I'm just going to paste this in. Let's throw it in here. Perfect. So I don't need this, and this can change back to, or no, that was a correct shortcut. Anyway, so now we have our example input. So we need to read it. Let's see, example input split. It splits automatically by white space. By new line. Sorry. Oh, okay. So that's actually a mistake here. This is not new lines. It will be given to us also in the example as a single line. So let's see. In our actual input as a single line. Yes. So that's perfect actually right away. So we already see our first. This is the enhancement algorithm that they provide. It's the first row in our data, and then the next rows are just the image. So we can hack this a little bit and just remember. Okay, we can just do like this for now. Yeah, I'll just because it's going to be the same for our actual input here, right? It looks like this, so it's one line and then it's like this image. So let's do let's make this into a function, I guess, also, or and name this. I can do it up here. Define read input. So let's say here input data, which is a string at first, and then it returns an oh yeah, we will need to import things. Import things, and this is code import numpy as p. We're gonna need numpy quite a bit this in this one, and it will return a numpy array because I really like numpy arrays. So we just take from the input data, we split it. So this is I'm gonna name this temp, and we know that actually it will return. Okay, let's make this a little bit nicer. From typing import union, or not union, tuple. Yeah, perfect. So basically what I'm gonna do here is I'm gonna say that array. Basically, you can, with type hints in Python, you can make it a little bit super nice. So typing is a built-in library in Python. It comes with it, and it has a lot of types. So tuple is a Python type, and then there's also a list. There's also like a union operation. There's a lot of ways to combine types for documentation, for hinting into types. So basically what I'm saying here to the user, this is only for the user, by the way. It does not apply some forced typing in Python or strict typing. There is some libraries that can do that for you. But here it just suggests that the input data should be a string, and the output of this function is going to be a tuple that contains two numpy arrays. So I'm just gonna do this. Let's see. So what we want to do is we have this input, and we want to convert it to, we want to map each hash to a 1 and each dot to a 0. So let's say if we take this one, I can do replace. Yeah, that's pretty simple. Dot with 0 and replace hash with 1, and then it looks like this, and that's perfect. And then I just copy out this one as is, and I'll do this actually in the first step here and I'll name this to binary, and we will directly convert our input data to this format. So now this is binary, then we will split it to multiple split. So I'm just gonna name this split. Yeah, why not? Great naming. And then split, and then we're gonna think. Yeah, and then we need and then we need to make the algorithm piece, which is going to be the first part of the split, which is this upper part here, and that we need to split again. This time we'll split it for oh no, we don't need to split it, sorry, because it's already it's already a string, which is an iterable, so we can actually iterate through all these characters. and say I want B for binary for B in this string. So then it will create exactly an array. It will basically read out each character in the string and expand it out to an array. And that is because in Python you can do that. You can iterate through lists. Sorry, that of course you can do, but you can also iterate through strings. Yeah. So let's do that here. I'm gonna do for binary for binary, or maybe actually even a bit more clearer. Binary, digit in split 1, 0. So now we have the algorithm, and then we're gonna make this into a numpy array. And also the image input, the image is just going to be let's see, let's do this here again. So let's take the image now is every row from, okay, that's a little bit more complicated. So it's every row from 1 all the way down. That's gonna crash, yes, because it's a list also. But if we, so in Python you can also do these nice. So that's the first row, but you can do this, and basically it tells Python to look at this is a list now, since the splits this by here. Exactly, it splits it by row, and as you can see, it also removed the empty row here in space, or at least I hope so. It looks like it. And if I ask for it, I can ask for it to only return everything from here on and skip the first one by doing this. So basically, this one is the first row. The second row there, and with the full colon we say I want from the first row all the way down. Also you can say like from first to fourth, and it gives you like these 3 rows or just all of them. So we're gonna do this. So let's see. So for binary digit for binary digit for each binary digit in the split 1 and on. So this let's see. So if we emulate this down here just for some exercise, it's going to be for I in here. It basically will exactly return the same thing. It will just unpack every array, every piece of this array, and will basically wrap it again inside a list, which it is actually exactly already what it is. But the reason for us to do this is because we actually want to perform an operation on those, and we want to do this. So now we are unpacking the array, performing an operation on it. Let's do it here. Oh. And now that we have this, let's see. I'm gonna do this the nasty way. I'm gonna say. Actually, we can remove this for now and say digit for digit in I. So then this is a nested list comprehension, and this will look into each of those separately. And the reason for that is, it will expand them to an array. So if I skip doing the replace for now, you'll see this was our initial input, and it's been basically spread out even deeper to a list instead of a string now. Before, this used to be one string, this one here, but now we look through it and just expand it out. So, and then I can still do that in here. I can even, I don't know if it's faster to maybe do here actually. So now it's an array like this, and if I make this into just a numpy array, perfect. It just is beautiful. Now the only thing I'm wondering is if I should make all these integers yet. Can I do this in here maybe? D type. Oh yeah, we can. So we can do int. Yeah, perfect. So then if we come back up here, we're gonna do the same. We're gonna make a nested list comprehension here, and in each. So this is actually, this is not binary digit here. It's binary. In this case, it's going to be an entire row. So maybe we should name it a little bit clearer. Binary row, or yeah, that should be okay. And in here we do binary digit for binary digit in the row. Yeah. Perfect. So let's make this a numpy array as well, and make it into an integer array, and then we can return algorithm and image in a tuple. You don't have to put parentheses around. Python automatically creates a tuple from just if you have the comma, but I think it's nice to show sometimes. It could be that people don't like that there is like these conventions on how to write Python, and it could be that I'm going against it now. Maybe it should be that we don't show the parentheses, but whatever. For now, let's do this here. Convert input data to readable arrays of to readable arrays of binary information for the algorithm and what's called and the image. Not a great description, but a raw input data from submarine system, and then this is our output, which is returns to a tuple of two items, the algorithm and the image. A tuple of two numpy arrays, the algorithm, and I'm gonna write this is n by 1 actually not even one. It's just I don't think it has dimension, and then the image is x by y, whatever dimensions it is. So perfect. So let's go back down here. We can now remove those and just say read input, and let's see if it worked. Example input, it seems like it did. So if I take this one, we see that's probably correct. We'll find out. Okay, yeah, that's at least the correct shape. It should be one long list, basically, array. And then the second output is 5 by 5. That seems correct. This is 5 and this is 5. Yeah, perfect. Yeah, so I think we got it. So we can say here algorithm and image, and Python will automatically unpack them to the correct variable. So because this returns a tuple of basically two variables, they will be automatically unpacked into these two variables. So now if we do algorithm, it'll be this, and image will be this. So that's perfect. So let's see now. So now what we need to do is we need a way to pad this image, and let's just give me a moment. I'll be right back in 5. See you soon. I believe I'm back in less than 5 minutes. I did not check the time. So, hey, welcome back. Nice to have you in the stream. Hey, everyone. So, let's see. Right, yeah. So now we have these in our inputs. So if we can skip this for now. So basically, what they say here as well, which is a pretty good hint, is that yeah, the string is exactly okay, perfect. 5 to 12 characters long. So this is the enhancement. Yeah, the image enhancement string. This is our algorithm here, basically. It's this first line. And yeah, okay, it's enough to match any 9-bit number. So basically, when we read these 9 bits and we map them into an integer, it will be an integer from this enhancement algorithm. And basically, out of these 9 pixels, we will create 1. So this sounds like compression, really, but they get away with it. No, okay, no, no, it's never mind. No, it's not compression, because we're only going to map each pixel. You'll see. So in the middle of this first group of characters, the character index 36 can be found. So the output, right? So because 34, yeah. Wow, I'm really I don't know. My brain really reads whatever it wants. So yeah, so the number here we read is 34, and this represents this. We're going to whatever the image enhancement algorithm tells us it is, which in this case the 34th element is a hash, which is 1. Then it will be this one here. Then this dot will become hash, and we keep rolling this. Imagine this as think of this as a window, and we roll it everywhere. And they right, and they give us, this is a little bit of a help here, actually, I realized. So they say that this is infinite size. So basically they say, you can convert this image into any dimensions you like, as long as what you keep adding is blank, basically. So like they did here. So they took this 5x5 image and expanded it out in this way. So likely what they did here is they expanded out, at least what I will do is expand it out to, also because it augments, yeah, it gets larger as well. So that helps in two things. What I'll try to do is to make it a multiple of 3. So in both, so n square as well, so that we can easily, we don't need to be careful about how we will move our 3x3 window around. So in this case, they run this window like this, blah, blah, blah. They update everything. Ooh, I wonder if the update should take place. Okay, that's something to think about later, after we at least get some functionality done. So they basically run from left to right. I mean, I don't know what they do, but I guess that's the way to go about it. And replace all the pixels that need replacing. If everything is 0, then I wonder, can we just... Oh, wow, my first, if it's 0... Wait, the 30... yeah, here. Oh. So in my case, for my own input, everything is going to be bright, like a 1. That is, if everything is 0. So all these pixels for me are going to be converted to white, or to hashes, or 1s. Interesting. So basically, if we run this one time, it gets augmented to this one. So you basically replace every pixel with the 8 pixels from the enhancement algorithm. And second time becomes like this. True, blah, blah, truly incredible. So the question is, how many pixels are lit in the resulting image? So this is going to be easy to calculate the way we are approaching it now, because because our image is this, and I can already do this in numpy arrays, which is beautiful. So it just gives me the total number of bright pixels, and that's our answer in the end. So what we need to do is pad this. So let me see if we can do this in a numpy pad array with zeros. Can we do like something nice here? How to pad numpy array with zeros? That's exactly what we're asking for. Yeah, so they're adding. They're only adding in this case like one a row and one column here, but there is. Of course there is. Numpy pad. Pad an array. There you go. So we take as an input the array and then the pad width, how many number of values padded to the edges of each axis. So let's test this out. What's this mode? When following constant is pads are a constant value. Yeah, that's what we want. I don't need to read through the other ones for now. The values to be set. So the default is 0, and that's fine. That's good enough. That's what we want. Star length. Okay. Let's do that. Let's take np pad and our image as the array, and pad width is going to be the number of values padded to the edges of each axis. Before one, after one, before n, after n. Okay, so let's try. So this is a tuple of tuples, right? So we have a two-dimensional image. Let's try to just add one in each dimension, like one pad. Yeah, look at that. Nice. So if I add 10, okay, it became a little bit out of control, but let's make this pretty by plotting it. Import pyplot as plot plt classic. So if I now do this here, if I do image, if I print this as an image, as if it was an image, you'll see, yeah, that's our starting point. Oh my god, that's super nice. Axes, false, and this one as well. Axis. Yeah, look at this beauty. So this is the starting point. In this case, so basically now. So what I want to do. Okay, we're also should be cautious about time. So let's see. This now became 25 by 25. So I want it to be divisible by 3. So let's see. Is 26? No, I'm bad with. Sorry, I'm bad with multiples. Okay, this is divisible divided. Okay, so then we do this, right? Yes, perfect. So this is the remainder or the mode operation. So we want this in order to figure out if something is divisible by something. The remainder should be 0 of the division. So let's see. Our image shape is 5 by 5, which is not a nice number. We want it to be divisible by 3. And And to do that, maybe for now we can handcraft this and be smart later. We only have 42 minutes at most. Okay, 27. So we want. So this we have. I can comment this one out for now. Just to keep a memory of this here. We have 5 by 5, and we need it to be 27. We don't need it to be 27, but we're gonna make it large enough to be 20. So then we need minus 5, 22. Okay. So let's take 22 in every direction, since it's a square array. So now it. Yeah, is that that's fine. That's fine too. It is not divisible by 3 though. Well, should it be like this or? Okay. Wait, no. I'm adding too much in each direction. What was we wanted? 27 minus 5, right? 22. So then it should be 11 in each direction. Why it looks a bit strange? Why did I do this? I messed up something. No, okay, yeah. Oops. Never mind. It was because Visual Studio Code is linting my code as if it's like one file. So I didn't like how this looked, I guess. So now we're at the correct place. So what we did is we took 27, which we like because we know it's divisible by 3, and then we said 27 minus 5 in this case, which is, so this is 0, this is I can write it like this is 22, and then we took 22 and divided that by 2, which gave us 11, which is and then I made this padding. So it's basically, the reason for 11 is because we want to add so many in each of the 4 directions, and I divided it by 2 here because we want 2, 1 left, 1 right, 1 down, 1 top. Perfect. So, and then this is padded image, and then this is padded image. Padded image shape, and now that works perfect. And so now we have a preliminary result. So this is where we start at, and now what we need to implement is the actual enhance. So now that we have the padded image, we need to let's see if we can do it with Python, with NumPy. Can we do like window something? Chef, polynomial, ticks, polynomial. Let's see. No, not really. Doesn't look like it. Maybe with SciPy. Let's just go back here. Let's close this. Say Python. It's not gonna window. How is it called? A rolling 2D rolling window NumPy. We can bake it. Mm, yes, we could. Yeah, let's just. It doesn't look like there is like a straight answer here, so let's just bake it. So and what I mean by bake it, we're just going to loop through everything and just hard code the where to look at pieces. So for row in range 1 to what's it called, padded image shape. Why is it not highlighted properly? What did I do? Let's comment this out and run everything again. Oh, what happened here? It completely commented out the. Oh, I didn't know you could do that. Ah, that was the problem. Yeah, sorry, that was not a Python cell. Yeah, you can, because we can have it was a string cell or like a markdown cell, and then we want to do for a column in the same range. But well, hopefully they're going to be yeah, and we want to start at 1 and 1. Right, so if I plot the image again, but this version here, yeah, so this is 1 and 1. So we want to start here, well, not in the padded image though, and look at the neighbors. Yeah, and then we also want to end here in the padded image. We don't want to, because what I'm trying to avoid is to have to roll over. Oh, but there is a problem though. Because my input maps zeros to a ones, that's going to. Oh, is that an error in my? Or did I misunderstand? Because it's gonna map everything into one. So if it's infinitely large, then the answer to my puzzle here should be infinite. But it doesn't take. Infinite. Let's try it out. Why not? No, okay. Because if it expands out infinitely large and every pixel is bright, then what's the size of the pixels that I should go with? Yeah, wow, shit. Maybe the first round. Okay, maybe the first round will be bright, but the second round maybe will dim everything. So maybe I can't cheat. Maybe I do have to. Damn it. Oh, 33 minutes. Okay. Maybe I have to. But it should be fine with the padding. I can just remove these in the end, actually. Yeah, we should be fine. Okay, we should be fine. So, for each. So we want to start from 1 to 1, and we want to stop if yeah, and we want to stop at I don't need to write this in. We want to stop at -1 here. I believe. Let's just test this. Print row call. Let's see where it started from. It started from 1 to 1, and it ended at 25, 25. That is correct, right? So if we take the image actually directly, like this, and print the content. Okay, it went out of bounds. Why? Yeah, because I'm reusing the wrong version. It should be the padded image. Yeah, good luck. But if I do use the image, just for test now, it should start at a 0. Let's see. Yes, this 0 here. And it should end at a 0 down here after a 1. Yeah, perfect. Okay, great. So we did this. Perfect. So let's use the padded image. And now what I want to do is we want to look at we want to fetch the top row, which is going to be like this, -1, column -1 to column +1. Yeah. Again, I don't know what's the proper way to like write this in Python. I don't know if there's like a nice Pythonic way, but I feel like I want to space these out because otherwise they look very dense. So then we have middle row, and then we have bottom row. So let's fix this. Actually, no, I don't need to. Yeah, row -1. No, that's correct. Then this is the current row, and this is the +1 row, the bottom row. And then we all take the same columns. Yeah, perfect. So then what I will do is I'll np np concatenate top row, middle row, and bottom row into a D type of string, and just print that. Let's see, and this should be our binary string. And can I make this to string? But let's do this for now. Binary string. I'll do row, column, binary string. Okay, so that is missing. That is not correct. It should be a 6, not 3. Is it wait, the padded image, top, middle, and bottom row. Maybe I have to make a copy. Is that the problem? No, I'm not seeing what did I do wrong. This should be this should be 9 digits, not 6. Top, middle, and bottom row. Maybe I can remove this one here. What? That is very strange. Maybe the concatenation function works a bit strangely in numpy. Concatenate. Maybe it doesn't take more than. Hey, welcome to the stream. No, it takes. It takes as many as we like. Is the axis is default 0? No. Okay, can we just print this one instead? Ah, okay, that explains it. Uh, but it should be. That should be. Wait, what? Wait, okay, my brain's a bit broken now. So let's try this. 0, 1, 2, 3, 4. Yeah, and let's ask for 1, 2, 3. Oh, okay. It does not. Oh wow. I don't. I didn't remember that it works like this. So maybe I made this mistake before. I'm trying to remember now. So this should be +2 then. And then this can be here the type string, and then this here can be a binary string. Perfect. So that's correct. Anyway, and so what we want to do is, can I do like for numpy arrays? Can I make them like to string or something? Array to string. That looks returns a representation. The array as a string. Oh, that's a lot of input. Oh, it returns it like this. Okay. But it's fine. We can do string comprehension. List comprehension here again. Or actually, wait. We can. I think we should be able to do this. So this is another cool trick in Python. You can take a string and any string, and say you wish to join this array together into a string by using this string in between them. So, for example, if I put commas, maybe that's a more classic one. You see, it converted it to a string with commas in between. Then I can do whatever, and it will do that. That's pretty cool. So we don't want anything here now, actually. So that's perfect. And because now this is going to be the input to our to int function, actually. So let's take this and say to int. So this is, yeah, actually I can just directly do it here. Join this as a, and I can make this a little bit nicer. Okay, we're starting to run out of time, but I have a feeling we're gonna make this. At least the first part of the puzzle. I'm not gonna do the second part now. So this binary string. Let's just put it here. Perfect. So it's returning some. Oh shit. That's not nice. Can I just also see the binary string? Maybe I made something wrong here. Always print your outputs. Oh, everything is 0. Something is very suspicious here. I suspect that I overwrote my padded image somehow. I did, yes. Okay, and I think I know why. Because I'm not taking a copy of it here. So let's actually make this a bit smart, like with multi-cursors. Amazing. So we. But how would it become? Anyway, let's run everything again, so that we have our input here. Oh, it's 0. Oh no. What happened to our padded image? It looks like this. Yeah, and it has a lot of zeros. So if we actually, so it was not a problem about this. I can probably remove that. It's still too early for me. So if I open this one here, we'll see eventually we'll find the middle where there is values. Yeah, here we go. And those. So now what we want to do is, since we have this, we want to. For each integer we get here, we want to use this in our algorithm as a index to get back replacement value and put this value in our padded image row column replacement value. Okay, we got this. So if I do this here, yeah. So let's do the printing afterwards as well. So moment of truth. So we run this once. It changed to this. Wow, it looks funny. Not shit. Okay, I think you know what is happening. We should make the update into a new. Yeah, I know what's happening. We should make the update into a new array, a new image, because now. But we're almost there. Okay, 20 minutes. I think we got this. So we need. So let's make a copy every time. Let's make a copy of the padded image. And operate on that copy instead. And that is going to be called... so first of all, I also should probably then change all these here. To a new name. Let's say enhanced image. Yeah, let's take this name and paste it up there. So now we have a copy of our image. Let's run everything again. And perfect. So now we need to change this to be the enhanced image. Yes. No, it's the same problem. Yeah, of course it is. Because, because this one here should be the padded image. Okay. I'm stressing out here. I think we can just run this again. Yes, okay. We got this. So this became this. I think we are onto that. Onto it. So now let's be smart about this. So we always want to keep the old version. So I'm just gonna hack this real quick here. Yeah, so we don't actually need to do this anymore. We have already done it. I know it will complain, but okay, yes. So now what I need to do is do the same thing the other way around. Okay, I'm gonna, for the sake of time, I'm gonna hard code this. Let's do this now. I think. Yes, I think it worked. Okay, so let's do the enhance image summary 35. Okay, it's time to do it with our real input. Let's do this. Oh shit. Oh wow. It took like these puzzles are so imbalanced like this one, I mean, it's also like if you have the solution in your head, you can actually do it. Wow, my hands are shaking. I'm so excited. Uh, so if you kind of know what you should do, I think it makes it quite a lot easier than be like in the day 19. I'm still trying to figure out, wow, what we should do. So let's back up here to this, and so we will need some more things to do here. So this is our example input, but we want to replace this with we want to read the file from data day, the one we created right now, day 20, puzzle, 15 minutes, 16 minutes, one, and then we want to open this file as f, and we want to input data as f.readlines, and I think this is going to look a little bit different now from our example input. Yeah, so I think I can let's see, join maybe like this. So I wanna we wanna replace these. Maybe there's a more elegant way to do this now, but I can't think. Yeah, okay. I need to clean them out a little bit. I'm just trying to map this to the. So this is going to be an array. I'm just trying to map this so that it operates well with our current implementation of the reading library function. So we have row for row in the input data, and we want to perform a replace operation on that to remove the these like the new line characters, and then we also want to actually join this, I think, with new line characters. Let's see. No, okay, never mind. That does not look good. Okay. Then I'll do it not the other way around. I'll just never mind the join. We can also, we don't want to keep the if. So if the row is equal to nothing, we don't want to keep it. So no, sorry. If it's not equal to that, yeah, true. No, but then that's still here. What? Okay, something is off here. Come on, don't eat my time now. So we need to convert it into like a unified string like this. There should be just a simple way to okay, but that's fine. Okay, it doesn't matter. Oh, what I'll do then is, I don't know why this didn't work. Okay, but what I could do is len row if the length of the row is greater than 0. 1 maybe. Okay, yeah, there we go. It's a way. Yeah, because that was the length 0. Sorry. Okay, we got this. This is our how should we name this? We have this one here. So then we can do I'll just do it a little bit quick, like here. Just copy this and comment this one out so that doesn't overwrite our previous things. So let's paste it here. Remove this. Perfect. Where do we go? Oh no, it did not work. List has no attribute replace. Yeah, because I'm already giving it a list, true. And it's trying to do this cleaning here. I made this too complicated for myself, or not too complicated, but come on, come on, come on, we can do this. Python join a list of strings into one string with new lines. But I want proper new lines. I don't want... Yeah, exactly. So this is what we tried. No, I don't want to print it. I want to... Oh, this is very old. This is Python 2 something. No, come on. Come on. Okay, 10... Okay, let's be smart. I think I'm gonna just do this now. I'm just gonna not read the input from here. So let's comment this one out for now. And just say here... input data is equal to... Just paste in... Oh no, what happened? Yeah, that looks correct. Just paste in this. Because we also have more things to do than that. Input data. Perfect. So the image is this. I want to know the shape of the image. It's 100 by 100. We need to make this a multiple of 3. And let's take, sorry, this one here, and modulo 3. Okay, if we give it 1. Oops, sorry. Plus 1. Hey, welcome to the stream. Plus 2. Okay, 102 apparently is multiple of 3. Alright, perfect. Okay. And but let's maybe give it a little bit more. Maybe let's, I don't know, a few more pixels. Just oh, 20. Oh, 120. It's a multiple of 3. Okay. Oh, nice. So we want to give. So we have 100 in this. In our case, we have 120. 120 minus. No, we already know. Sorry. We already know that it's 20 pixels we need to add, so that's divided by 2, 10 by... So then that's going to be 10 in each dimension. Okay. Let's print it. Okay, that looks like a QR code. Okay, let's do this. Let's enhance one pass. Print it. Okay, and I suspect now... Oh, let's see that if we run this again... Please, please, please work. Oh, shit, it looks like... Okay, we'll attempt this one first. I think this is probably going to be wrong. What I'm going to do, though, just going as a hack, I'm going to remove these extra lines here, I think. So let's try this out. Because I suspect that this is a problem. No, okay. But it's fine. Let's see now. So what I can do is remove the padding. So remove 10, 10, 10. Okay. So then, let's see. If I do here 9, 9 all the way to what is it? What was the dimension of this? 100. Okay, 9 all the way to maybe 110, and the same for this axis. Yes. Okay. That. Oh, that maybe looks too tight. Let's make this 5. And wow, this is pretty much like cropping an image. 2. Okay, needs a bit more, maybe 4. Okay, yeah, that looks better. So let's try to take the sum of this. Oof, I think we're gonna make it. And now, okay. Oh, give it to me, please. Yes, high five. Nice. Damn, we got this. No time for part 2 though. Let's see how. You still can't make out the details in the image. Maybe you can just enhance enough. Enhance starting input image in the above a total of 50 times. Whoa. Okay. Oof. Maybe we can do this. Because we always need to replace. Oh shit. Okay. Okay, my first meeting is at 9:15, so technically, I could spend more time in the evening. Okay, so we need to. Yes, we need to loop loops or like enhance times. So let's say now it's 2 for enhance in range enhance times. We want to run this and so when we start we want the enhanced image to be this, but in every iteration enhance the image, and then we will also create a temp image. So this will be np zeros of dimensions equal to enhanced image shape. Yeah, maybe actually that's actually good enough. And what I'll do is that the enhanced image here, I'll rename it to temp image. And let's think. Okay, wait. So we go in. We have a copy of our padded image into the enhanced image. That's our first enhancement pass. There's no enhancement. That's our 0th enhancement pass. We have an empty image, which, okay, here. Yeah, I think what we can do is actually move this in here. And we don't. Oh, wait. Wait. So, okay, let's think about it. We take the padded image, put it in the enhanced image. So now the padded and the enhanced are the same. And in the first pass, we will be reading from the padded image. So we can throw out the we will be reading the padded image only the first time, which is the enhanced image. So then here I can change this to enhanced image as well, and I can operate on the temporary image. And when this all is done, yeah, so this, okay, perfect. So then this I put here, this I remove completely. And once all this is done, oh shit, okay, doesn't matter. I will then replace the temporary image with, the enhanced image with the temporary image. And then clean the temporary image. Okay, so this now If I run this already... Oof. Okay, so maybe I messed something up. Let's run everything again. Come on, we got this. Did it run now? It did. Okay. So what's the problem here? Invalid literal for integer with base 2. It has dots between. What are the dots? Is the temporary image like wait, what's the temporary image? Oh, okay. Got it. Okay. No worries. We need to make sure that this is an integer. Okay, it worked. Oh, yes, it worked. Okay. Perfect. And that was that what I copied before? Yes. So let's change this. Oh my god, we're gonna make it in time. 50. Let's do this. No, it became a... Oh yeah, because of this one. Ah, I'm stupid. Is int as well. Please. Okay, that's taking a while. No, don't run over time. Are we doing 50 times? Yes. Oof, that's slow. Oh, please. Oh, we're okay. We're over time. But okay, it's over. It has expanded out a bit too much, maybe. Oh, I don't like that. Oh no, it is. Okay. I think this is gonna be wrong. Yeah. Too low. But good that I noticed that. Okay. I'll just expand the array a little bit more, which is probably going to take even more time. So we need something that is divisible. Let's take like a large one. 110. I don't know. Yes, 100. Okay, 110. And divided by 2, it's 55 in each dimension. 55, 55, 55, 55. Okay, let's run everything. That's gonna take even longer. Okay, we're over time. But we'll get... Let's see. Am I getting called out on yet? Okay. Okay. Let's see. I think we still have maybe a little bit of time until this starts working. Oh wow! I hope it doesn't. Maybe we should put a limit on how long it can take. This is not very. Oh no! That looks cool, but also. Okay, that looks like I need to... Okay, maybe I'm doing something wrong here. We make a copy of the enhanced image. I think something is going off here. Okay, I'm gonna call it a day now. We're over time. So thank you everyone for watching. Hope you have an awesome Monday and an amazing Christmas week. And see you when we see you in this irregular streaming schedule. So have an awesome day.